Continuing on, we're now looking at the Cartesian plane. So the Cartesian plane is this sectioned graph that we have, right? Each little block. We typically have each unit as one. We have the horizontal axis, which is our x-axis. We have the vertical axis, which we call the y-axis. The point of intersection of the x and y-axis right here, or if you want to call it the point 0, 0, is called the origin. And then each of the quadrants, right, each one of these sections that are broken up by the axis intersection have their own name, and it goes in counterclockwise direction. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So something we're going to do here in a second is we're going to plot a point and then say, okay, what quadrant are we in? Okay. Now you notice the origin here I put as this parenthesis 0, comma 0 parenthesis, right? Well, that we call an ordered pair. Okay. And that's a set of x and y, right, you see here. And we call that the x coordinate and the y coordinate. So let's go ahead and take a look at a few of these and see if we can't plot them and then describe what quadrant they are in. All right, so first we have point A, which is at 3, 4. So again, remember this is x and then y. So by the way, this is positive x in this direction, this is positive y in that direction, this is negative x, and this is negative y. Okay. So it says go 3 units in the x. So 1, 2, 3, okay. And I should be careful of drawing a line here. So we're 3 in the x. So I don't know if you can see my cursor right here. That's not the point I want to draw though. So I'm over 3, and then I need to go up 4. So right here is where I want to be. Okay. So over, oops, sorry. Looks like I went over too far. You go over 3, up 4. There we go. That is point A. So let's draw all of them, and then we'll say what quadrants they're in. That'll be quicker. All right, so now we want to do point B. That is -2, 1. So I'm going to this direction, right? -2 in the x, and I'm going up 1. So it looks like I'm right there. So I'll draw these little marks, and then I'll erase them so you can see how I'm getting to the points. So this is point B. All right, point C says go +7 in the x. So I'm going 7 units this way. So I'm there. Then I need to go -3 units in the y. So 1, 2, 3. This is my point. Get rid of all my little squiggles. And this is point C. All right. Keep going. Let's do point D. Now D, notice, is -4, -2. That's -x, -y. So that means go left and then go down, right? -x is left, -y is down. So -4 and then -2. So that puts me right there. Now these next two are interesting because notice the first one has an x of 0, the next one has a y of 0. So that's actually going to make them not in any quadrants. So E is 0, 5, which means nothing in the X, and then go up 5 in the Y. So don't go X and then just go up 5. So that puts me right there. And then F says go down 1, right? -1 in the, I'm sorry. It's -1 in the X. That means go left 1. Silly me. Go left 1. And then nothing in the Y. So left 1, and then nothing in the Y puts me right there. All right, so let's describe what quadrants these are in now. Okay, so in A, or point A is in, remember this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So A is in quadrant 1. B is in quadrant 2. Then C is in quadrant 4. D is in quadrant 3. E is is not in a quadrant. It is on the y-axis, and F is on the x-axis. All right, so let's continue here. We just got done looking at how to plot points. Now we would like to talk about how to plot equations. So the easiest way to plot an equation is, or I guess the most basic way, is to just do a table of values. So you'll see next to my Cartesian plane down here on the right, I have a table which has values of x, and then I have a section for y. So in order to do this, we simply need to take the values of x in the table, substitute them into the equation, and generate a value of y. So this is, as the second bullet point says, substituting values for the independent variable, that's x, and evaluating the remaining expression using the order of operations. That gives us our y value. Then use the table of values, right? The x and the y, which are ordered pairs. Plot those ordered pairs, and then you're going to connect them, which creates a sketch of the graph. Now, in some cases, having some understanding of the shape of the graph is really good to know. So I'm going to go through that as we're working on these as well, right? Because you could technically connect 2 points in any way you like, right? It should be a line, right? I don't know if you guys know that the 2 points defines a line. But let's just, get a little bit of knowledge about what these functions look like. All right, so for these examples, we're going to be asked to complete the table of values, plot the points, and then sketch the graph. The first example is y equals x minus 2. Okay, that is a line, right? We should know that a line is of the form y equals mx plus b. So we should be expecting that this produces a line. Okay, let's go ahead and plug in the values. So I gave some space here for y because I actually want to do the calculations over here for at least a few of them. So we are plugging in -3 for x. So if I rewrite the expression for y, or the equation, right, it's -3 getting plugged in for x minus 2. Well, you really don't need the parentheses there. You could drop them. So then you have -3 minus 2, or if you'd rather, plus a -2. And so that's going to be -5. So my first ordered pair is -3, -5. Okay. Now I'm just going to keep doing this for each of the values of x. Plug in -2. That's going to give me -2 minus another 2. That's going to be -4. You might start to see a pattern here. And this is because it's a line and because of how the slope is changing. So here we're plugging in -1 minus 2. Well, that's -1 minus 2 more. That's -3. So as you notice, our values of y are going up by 1. And if you look at the slope, if you look at our equation of our line, the slope is the number in front of x. In our case, it's a 1. So that's why we're going up by 1. All right, so 0, we plug that in, right? We're going to get -2, and we're going to get -1, 0, and 1, right? As we said, we're going up by 1 each time. And that's only because this is linear, okay? All right. So now that we have all of our ordered pairs, we need to plot them. So x is -3, y is -5. That's right here. Okay. Then -2, -4. Right here. -1, -3. That's left 1, down 3. Now, again, you're noticing a pattern, right? I'm going from my first point to my next point. I am going right 1, up 1. Again, my slope, m, is really 1 or 1 over 1. So again, that's why we're moving in this type of fashion. And this is only for linear functions. All right, when x is 0, I'm at -2 for the y. When x is 1, I'm at -1 for y. When x is 2, I'm at 0 for y. And finally, when x is 3, I'm at 1 for y. So let's see if I can do a decent line here. Probably not. It's a little hard to do on the computer. Okay, not too bad. So that is the graph of the equation y equal x minus 2. Okay. So not too bad. You plug the numbers in, plot the ordered pairs, connect the dots. All right, let's continue and take a look at another type of function here. Now notice this one has an absolute value. Now this one's not something that you may have dealt with before or remember very well if you have. So I'm not expecting you to know too much about what this is going to look like. Right, well, we call these things parent functions. So just an absolute value function is going to look like this. Okay. Now, ours might be flipped over, it might be shifted left or shifted up or whatever, but that's the parent function. That's what just absolute value of x looks like. So we're expecting some kind of V shape out of this thing, okay? Now, again, you don't have to know that. It's just nice to know before you start working. So let's go ahead and plug in the values again. I think I'm going to start at 0 this time, just to make things a little simple. So I have -2, and this time, because of the parentheses, I normally would put, I'm not going to put them because we already have the absolute value symbol. So -2 times the absolute value of 0 plus 1. And let me just go back and explain what absolute value is real quick, because we might not remember that as well. So the absolute value is really a measure of distance on a number line from 0. So for instance, the absolute value of 2 is 2. It's 2 units away from 0. And the absolute value of -2 is also 2 because it's 2 units away from 0. It's just the measure of distance. It doesn't care whether it's to the left or to the right. So absolute value, another way to think of it, is it always gives you a positive value back. Okay, so no matter what you plug in, you get positive. Now 0, well, that's just 0. So the absolute value of 0 is nothing. -2 times nothing, right, or 0 is 0 again. And then +1 gives us 1. So the first ordered pair that I found was 0, 1. Let me just go ahead and plot. So 0 in the x means I don't go left or right, and then up 1 in the y. So I'm right there. Okay. Let's continue to plug numbers in. -2 times the absolute value of 1 plus 1. Absolute value of 1 just returns 1. -2 times the absolute value of 1, which was 1, is just -2. And then -2 plus 1 is -1. So let me just do that again. All right, it's -2 times absolute value of 1 plus 1. That's -2 times 1. That's -2 plus 1, or -1. Okay. Now, the neat thing is, because it's absolute value, right, when I plug in -1, I'm going to get the exact same answer. Because the absolute value of -1 is the exact same as the absolute value of 1. So absolute value, if I plug in a -1 here, still gives me this. So I get the same exact answer. So let's plot both of those. So when x is 1, I go down 1. When x is -1, I also go down 1. So you can already see I'm getting that V shape, right? All right, now if I plug in 2, so -2, absolute value of 2, plus 1. Absolute value of 2 is just going to be 2. -2 times 2 is -4. And -4 plus 1 is -3. So that says when x is +2, go right 2. Y is -3, so go down 3. All right, and you could guess from the symmetry that we've already seen that when I plug in -2, I'm going to get the exact same answer as when I plug in +2. So when x is -2, I go down 3. All right. And then finally, if whether I plug in 3 or -3, I'm going to get the same solution. 2 times -2 times 3 is -6. -6 plus 1 is -5. So I get -5 for both of these. So when x is -3, I'm down 5. And when x is +3, I'm down 5. Okay. So again, let's see if I can draw this. Okay. That's my absolute value function right here. All right. I think we have one more here. So y equals 6 minus x squared. Okay. So x squared, parent function for that is a parabola. Right. This is the parent function. And that just means that we haven't, moved it around or anything. And a basic parabola looks like this. Okay, so that's the kind of shape that we're expecting. Again, it's going to be shifted, flipped, whatever, depending on what kind of operations are being done. So again, I'm going to start at 0. So I have 6 minus, and instead of x, I'm plugging in 0, and I'm squaring it. 0 squared is still 0. 6 minus 0 is 6. So don't go anywhere left or right. Go up 6 units. Okay. Later on down the line, you'll call this the vertex, by the way. Okay. Let's plug in positive 1. So I have 6 minus negative 1 squared. Negative 1 squared, as we discussed earlier, is negative 1 times negative 1, which is 1. 6 minus 1 is going to be 5. And if I go up here and do the negative 1, I'm sorry, I just did that here, silly me. All right, so positive 1 squared is 1, 6 minus 1 is 5. Negative 1 squared is 1, 6 minus 1 is also 5. So both of them are the same values. So when x is 1, I'm up at 5. When x is negative 1, I'm up at 5 again. Right, so let's do 2. 6 minus 2 squared. 2 squared is 4. 6 minus 4 is 2. And if I plug in the negative counterpart, right, negative 2 squared is also 4. 6 minus 4 is still 2. So I get 2 for both of those. So those ordered pairs are 2, 2, and negative 2, 2. Okay. Finally, let's plug in 3. So 6 minus 3 squared. 3 squared is 9. 6 minus 9 is negative 3. So we're going to get that here as well. So the ordered pair is 3, negative 3. And then negative 3, negative 3. All right, so this looks a lot like the absolute value, but it's not nice straight lines this time. It is more of a curve because it's parabolic. Okay. Forgive me for the not so great lines. It's a little hard to do this on the tablet surface. All right, so those are 3 examples of plotting functions using a table of values. We did a linear function, we did an absolute value function, we did a quadratic function, or what we would call a parabola when plotted. Some of them have symmetry, we've noticed. There's a lot of things that are coming up that maybe we don't necessarily need to know yet, but we can continue start to discuss. So that'll conclude this section, and we'll go on to the next.